Hello everyone. In this video, let's discuss about the response of a first order RC circuit with a ramp input. Okay. So here, let's assume this time is equal to here the place where input ramp starts is 0 seconds, and the signal will be giving as V in of t equal to m into t volts. Okay. So m is the slope of the input. Okay, and t is the time. Here till 0 seconds V in voltage is 0 volt. In the same way, here I am considering the capacitor which has the initial voltage Vc of 0 equal to 0 volt. So that till 0 volt Vc voltage will be 0 volt. In the same way, current will be 0 amperes, and the voltage across the resistor is also 0 volt. To analyze this circuit from 0 seconds to t is equal to infinity time, let's consider two cases. Let's analyze in two cases. One case is at just after 0 seconds. This is one condition. Second is t equal to infinity seconds. Okay, if I analyze these two conditions, we can draw how the VC voltage will behave. Okay, how the circuit will behave. Okay, let's analyze at t equal to 0 plus. Okay, t is equal to 0 plus means we are considering only a single point. Okay, let's assume this is a t is equal to 0 plus. There will be some fixed voltage. Okay, we are considering as a fixed voltage at only that particular point. I'm not considering from whole area. I'm considering only at that particular 0 plus instant where voltage just started. Mean voltage just started. Okay, at that time, if I redraw the circuit, I can redraw with resistor and a capacitor. This is the V in, and this is the cap, and this resistor. Here, if you see, because I'm considering only at one particular point, this V in we can write as a fixed V volt because I'm only considering at only fixed point. Because the capacitor starts seeing the voltage from 0 to some volt, capacitor will act as a short circuit here. Okay, this is a short circuit. So the current flowing to the circuit at that t is equal to 0 plus will be voltage V divided by R. Okay, resistance R. Because here the finite amount of current is flowing to the capacitor will not charge instantly. Capacitor will take some certain amount of time to charge. Okay, and this has an inherent delay of the capacitor to charge is being introduced by RC. Okay, this R value and C value. Okay, so here if I wanted to derive what is the current flowing to the capacitor, not only t is equal to 0 plus, and after some amount of time, like let's assume till starting. Okay, till here what is the current flowing through the circuit. Okay, if I draw that one, V in will be V will be m into t volts. Okay, because the voltage is not fixed, is ramping with slope of m and t. Okay, so I will be, that means I of t will be V in divided by R, which is equal to m into t divided by R amperes. Okay, because you can see this is m and R are the constants, but t is the thing which is varying. If I see what is the, because of this current flowing to the capacitor, what will be the voltage across the capacitor? If I draw Vc of t, this will become 1 by c into integration of I of t into dt. So if I substitute I of t here, this will become m by r into t square divided by 2. This is Vc of t. Okay, here if you see during the starting, the capacitor voltage has a parabolic nature. Okay, this capacitor has a voltage has a parabolic nature. This is like this parabolic nature starting from 0 seconds. In the same way, the current, we understand that by seeing this formula. Okay, being this formula, current is a linear. Okay, and the voltage VR is simply VR is equal to I into R, so that it will follow the profile of the current. Okay, till what time this parabolic nature will be there. So till the delay of the circuit. Okay, the capacitor has an inherent delay which is RC. Till that RC, which I'm taking as a tau. Okay, till tau time the capacitor will behave as a this parabola. Okay, so I am telling after 0 seconds, after till 0 seconds I am telling from 0 seconds to some point I took. So this point is tau seconds, RC seconds. Till tau RC seconds the capacitor will behave, voltage will behave as a parabolic in nature. So this is what this after 0 seconds means, till tau seconds, till RC seconds. Okay, let's analyze what is the behavior of the capacitor at t is equal to infinity. Okay, at t tends to infinity. Okay, t tends to infinity seconds, what will happen? Okay, so the capacitor tries to match with the V in voltage. Okay, this is, let's assume this is the V in voltage. Okay, at capacitor will be parallel, so this will be parallel, tries to, this is VC, so tries to match with the V in voltage. Okay, the parabolic nature is gone because the delay, inherent delay of the capacitor RC is already gone during the starting, so that VC always tries to match with the Vin. But whether it will match with the Vin at infinity time, no. Why? Because Vin is also rising, because it has, VC has an inherent delay during the starting, which is the tau seconds. Because of the tau seconds, the VC will never match with the Vn, so that there will be inherent delay here. There will be inherent delay between VC and Vn till infinite amount of time. Okay, VC will never meet with the Vn, but the difference between Vn and VC, there will be a fixed amount of delay, fixed amount of difference, not delay. I should consider a fixed amount of voltage difference will be there between the Vn and VC. So how much will it will be? Okay, because here I consider Vn as m into t, so that VC will be, VC of t will be in the same way m into t minus tau. Why? Because VC of t is starting after tau delay. Okay, after tau delay it starts to ramp. Okay, that's why we consider as same as Vn, but it is starting from the some delay which is tau. Okay, so this V in minus, so in the steady state at t is equal to infinity, okay, there will be some delay. Okay, so if I redraw from 0 to infinity, that VC will be like this. During the starting this will be parabola, but after that it will be uh, tries to, it will be, VC will be parallel to Vn. If I draw the Vn also here, this will be like this. Okay, so understand that this is very parallel, so there will be some fixed difference between Vn and VC. So this is how much difference. Okay, so Vn is m into t and VC is m into t minus tau. This delay will be m into tau. Okay, m is the slope of the input and tau is the RC. Okay, so here if I draw the I, because there is a fixed difference in the Vn and VC voltage, so that I will be at infinity time t is equal to infinity only. I will be Vn minus VC divided by R. Vn minus VC is m into tau, okay, divided by R. Okay, and if I, and Vr is equal to I into R, this will be m into tau. So this is, you can say that after t is equal to infinity, there is a fixed current is flowing through the circuit, so that after some time this will be constant, this VR current, this is a current flowing through the circuit, this is constant, which will be m into tau divided by R, and this will be, VR will be m into tau. Okay, and let's see, I have simulated the same circuit. Let's see what is the circuit look like. Okay, so here this is a circuit which I have simulated. Okay, this is the V in, which is a ramp, and this is the VC, and this is the VR, and this is the IC. Okay, current flowing to the circuit. You can see during the starting, you are not observing here, there is a exponential here, but the current, you can see there is a ramp, this is a fixed ramp. Okay, till here there is a normal, it's following a t, m into t. Okay, m into t divided by this has a slope of m into t. Okay, and if you can see this resistor current after some delay, tau delay, this is fixed at 200 microampere. In the same way, VR is equal to I into R, so that it is being fixed at 20 millivolt based on the R and C value, R value which I have chosen. And VC always tries to match with Vin, but it will never meet with the Vin. Okay.